Inverse Laplace transform by using direct method. Apply the concept of Laplace transform to find L inverse of f of s, where f of s is 3s plus 4 by s square plus 9. For this, we can apply direct method. F of s is 3s plus 4 by s square plus 9. Resolving this function, that is in the form of p of s by q of s as 3s by s square plus 9 plus 4 by s square plus 9. We have resolved them into simple partial fractions. Now it is in the S space, we can apply inverse Laplace transform on both sides of this equation. L inverse of f of s is L inverse of 3s by s square plus 9 plus 4 by s square plus 9. We have the formula L inverse of s by s square plus a square is cosine at. To find inverse Laplace transform to this first term, you can use this formula. Later, L inverse of 1 by s square plus a square is 1 by a sin at. Use these two formulae to evaluate this function. Now, L inverse of 3s by s square plus 9 became 3 is constant. Outside of that, L inverse of s by s square plus 3 square, instead of a we have 3 here, so that L inverse of s by s square plus 3 square became cosine 3t. Plus 4 is constant outside of the Laplace inverse Laplace transform, that is L inverse of 1 by s square plus 3 square, that is 1 by 3 sin 3t here. Hence, which is the required inverse Laplace transform to this function by using direct method. Next question, find inverse Laplace transform to the function f of s, where f of s is s square negative 3s plus 4 by s cube. By using direct method, let this function can be assumed as f of s. S square by s cube became 1 by s negative 3 by s square, since 1s cancel, you have a 1 by s square plus 4 by s cube. It is in the S space, we can apply inverse Laplace transform. L inverse of f of s is L inverse of 1 by s negative 3 constant according to linearity, L inverse of 1 by s square plus 4 by L inverse of 1 by s cube. We know that inverse Laplace transform to 1 by s is 1. Inverse Laplace transform to 1 by s power n plus 1 is t power n by n factorial. So use these two formulae to evaluate these inverse Laplace transforms. L inverse of 1 by s is 1. We have written 1 here. Negative 3 constant. L inverse of 1 by s square. N plus 1 is 2 here. N is equal to 1. So 1 by 1 factorial into t power 1. That is only t. There is a plus. 4 is constant. 1 by s square can be written as 1 by s power 2 plus 1. That is why n is 2 here. So 1 by 2 factorial into t square by 2. 4 into t square by 2 is 2t square. Hence, which is the required inverse Laplace transform to this function. Find the inverse Laplace transform to this function 2s plus 1 by s into s plus 1. Let us assume that this function has f of s. Now it is in the form of p of s by q of s. Now without actually applying resolving into partial fractions, we can simplify them into partial fractions by direct method. First of all, you have a 2s, that 2s can be rewritten as s plus s, and the last two terms grouping as a single term. Now we have s by s into s plus 1 plus s plus 1 by s into s plus 1. Now this s cancelled, you have a 1 by s plus 1 plus, now s plus 1 cancelled, we have 1 by s. Now it is in the s space, we can apply inverse Laplace transform on both sides of this equation. Therefore, L inverse of f of s is L inverse of 1 by s plus 1 plus L inverse of 1 by s. By using linearity property. We know that L inverse of 1 by s plus a is e power minus at. At the same time, to evaluate this thing, you must have L inverse of 1 by s is 1. Now, according to these formulae, we have L inverse of 1 by s plus 1 is e power minus t, plus L inverse of 1 by s is already 1. Hence, which is the required inverse Laplace transform to this function by direct method. Next question. Find inverse Laplace transform to the function s by s square plus 1 times of s square plus 4. How we can achieve this kind of inverse Laplace transforms to the given function, that is in terms of the variable s. Now let us assume that this function as f of s. Now we know that 1 by s square plus a times of s square plus b is equal to 1 by b minus a 1 by s square plus a negative 1 by s square plus b, provided that b is greater than a. You can simply write 1 by b minus a times of 1 by s square plus a minus 1 by s square plus b. According to it, s is a common factor. Now 4 is b, 1 is a, so b minus a is 4 minus 1, that is 3. Just we have written 1 by 3 times of 1 by s square plus a. We have assumed a is 1 here, 1 by s square plus 1 minus 1 by b is 4 here, 1 by s square plus 4. This is just how we can simplify this function as sum of partial fractions. Now 1 by 3 is constant. Now s can be brought into the both the numerators in the respective terms. S by s square plus 1 minus s by s square plus 4. Now it is in the completely s space. Now we can apply inverse Laplace transform throughout this equation. L inverse of f of s is 1 by 3 L inverse of s by s square plus 1 minus L inverse of s by s square plus 4. We know that L inverse of s by s square plus a square is cosine at. Now here these two functions in the form of s by s square plus a square, use this formula. We have to evaluate these two inverse Laplace transforms. 1 by 3 L inverse of s by s square plus 1 square. Instead of a, we have 1 here, that is why it became cosine 1t, that is cosine t, minus L inverse of s by s square plus, you can write 4 in terms of 2 square, that is here a is 2, so we get cosine 2t. Hence, which is the required inverse Laplace transform to this function by an application of direct method.